GM had a decade-long head start on Tesla. They had the patents, the factories, the brand trust of generations. Then they crushed every electric car they built in an Arizona desert rather than sell them. That single decision handed the electric future to someone else. In 2026, that someone else just did something no one saw coming. They eliminated the one chemical that every battery factory in China, Europe, and the United States depends on to function, and replaced it with a dry process so structurally different that competitors cannot simply copy it. They would have to demolish their factories and start over. This is not a story about a better battery. This is a story about a manufacturing weapon, one that makes a $30,000 Tesla profitable, makes a million-mile battery possible, and makes China's entire battery supply chain structurally obsolete at the same time. Most coverage has gotten this wrong, because explaining it correctly means understanding chemistry, factory economics, and geopolitics simultaneously. That is exactly what this video does. Stay with it. Tesla didn't win because of genius or marketing. Tesla won because it was the only company willing to bet everything on a technology that legacy automakers were actively suppressing to protect existing revenue. GM had the patents, the factories, the brand trust of generations. They returned every check customers sent begging to buy the EV1 fleet, then crushed the cars anyway. The pattern isn't unique to GM. Kodak had superior digital sensor technology before the film-to-digital transition and chose to protect film margins instead. Nokia built more durable phones than Apple and chose to defend hardware while iOS rewrote the rules entirely. These weren't failures of intelligence. They were failures of vision, an inability to recognize that an industry's foundation was being replaced, not upgraded. That distinction is everything right now. Because in battery manufacturing in 2026, the foundation is being replaced, and the companies still running the old process aren't simply behind on a curve they can close with investment. They are paying a structural cost penalty on every single cell they produce, one embedded so deeply into their factory architecture that removing it means rebuilding from zero. You cannot optimize your way out of a foundational error. Every major battery manufacturer in China, Europe, and the United States, with one exception, currently produces battery electrodes using a method called wet slurry coating. Here is what that process actually involves at a technical level. Manufacturers take cathode powder, the active material responsible for storing electrical energy, and dissolve it into a liquid solvent called NMP, or N-methyl-2-pyrrolidone. This creates a dense chemical slurry that gets applied in thin, precise layers onto thin metal foil. To convert that wet slurry into a usable solid electrode, the coated foil then travels through an industrial drying oven that stretches longer than 100 meters, running continuously at temperatures between 130 and 150 degrees Celsius. That is a city block of industrial heat deployed for the sole purpose of removing a toxic solvent that had no reason to be introduced in the first place. But the thermal removal of NMP creates a second problem that is far more damaging than the energy cost. As the solvent evaporates from the surface of the wet electrode, it physically carries polymer binder particles upward with the vapor flow. The result is called binder migration. The top surface of the electrode accumulates excess binder, forming a dense layer that blocks lithium ions from moving efficiently through the material. The bottom surface, pressed against the metal foil, ends up binder deficient, which causes microscopic structural cracking after only a few hundred charge cycles. This is the actual mechanism behind electric vehicle battery degradation, not a fundamental limitation of lithium chemistry. A manufacturing defect, introduced at the molecular level during production, distributed uniformly throughout the electrode structure, and therefore essentially undetectable by standard quality control before the cell ships. Every cell passes its initial test. The degradation only surfaces hundreds of cycles later, inside the vehicle you already purchased, at the precise moment when the warranty conversation becomes considerably more complicated the sales conversation was. If you own an electric vehicle built by any manufacturer other than Tesla today, those structural flaws are sitting inside your battery pack right now, progressing through their degradation curve every time you plug in. Tesla's patent US 353645662 describes the second-generation dry electrode process running at Gigafactory Texas right now. No NMP, no 100-meter drying oven, no binder migration. Instead, dry cathode powder is mixed with PTFE, commercially known as Teflon, then forced through a process called high-shear airjet milling. Compressed air accelerates to supersonic speed inside a sealed chamber, blasting dry particles into violent collisions at extreme velocity. Under that level of mechanical force, PTFE molecules don't stay spherical. They stretch into microscopic fibers, hundreds of times thinner than a human hair, weaving through and around the cathode particles in every direction. The result is a three-dimensional mechanical web. No liquid chemistry, no temperature-sensitive solvent, no migration, just structure. Think of it this way. The wet process holds electrode particles together like wet glue. It degrades when conditions shift or drying is uneven. The dry process weaves those particles into an interconnected fabric, structurally stable under heat, mechanical stress, and 10 years of charging cycles. The production numbers that follow are hard to ignore. Wet process requires 10 calendaring passes. Dry process requires 3, a 70% reduction in mechanical processing stages, which directly enables faster line speeds, more electrode area per hour, and less compounding error per cell. The energy saved by eliminating those 100-meter ovens running at 150 degrees Celsius across a full gigafactory, equivalent to powering the New York City subway for 5 consecutive years. That is not a marginal efficiency gain. That is a structural cost advantage that widens every single year. On longevity, dry electrode cells retain above 90 funcham capacity after 2,000 full cycles. Wet process cells show measurable decline between 500 and 800. At normal driving distances, that gap is the difference between a battery assessed at year 7 and a battery that outlasts the car itself. There is a dimension to this story that almost no automotive channel addresses directly. The wet process doesn't just create engineering problems. It permanently embeds geopolitical dependency into your supply chain, in a way no manufacturing efficiency can remove. NMP, the solvent at the center of every wet process battery line, runs through a chemical supply chain that China controls approximately 80% of globally. Every battery manufacturer outside China running the wet process is structurally routing their production inputs through a supplier nation that has already demonstrated willingness to weaponize export restrictions on critical materials. The dry electrode process severs that dependency completely. PTFE is manufactured domestically at scale inside the United States. The milling and coating equipment is sourceable from domestic and allied suppliers. Gigafactory Texas can run from raw input to finished cell without a single critical chemical sourced from an adversarial supply chain. When your inputs are domestic, a foreign export ban is background noise. When they aren't, a single policy decision in Beijing can halt your factory within weeks. One clarification the record requires. Musk confirmed publicly in May 2026 that dry electrode mastery applies to the cathode only. The anode remains an unsolved engineering problem at production scale. This technology is real, it is shipping, and it is unfinished. Whoever solves the anode first, Tesla, BY, Toyota, or a company not yet in the headlines, gains a compounding cost advantage on every cell produced after that moment. GM destroyed the EV1 because institutional short-termism killed a technology that could have given American industry a 15-year head start on the world. The companies currently perfecting wet process production are making the same structural error with a longer time horizon. At mature scale, dry electrode cells are projected to reach $60 per kilowatt-hour. Current best-in-class wet process cells cost $100 to $120. At $60, a base Model 3 prices below $30,000 while remaining profitable. That threshold has been the stated goal of the global EV industry for nearly a decade. The dry electrode process is the most credible disclosed path to reaching it this decade. But the tension honest coverage cannot avoid is this. As Tesla's manufacturing becomes more proprietary and more vertically integrated, the vehicle becomes a closed ecosystem. No independent part sourcing, no third-party repair, no modifications. Tesla's schedule, Tesla's pricing, Tesla's terms permanently. You are not buying a car. You are buying membership in a manufacturing philosophy that offers advantages no competitor can match. In exchange for surrendering independent control over the most expensive machine your household will ever own, GM couldn't see past the next earnings report. Tesla built the alternative. That alternative is now constructing infrastructure that appears genuinely unreplicable by any competitor within a strategically meaningful window. Whether that outcome is progress or a new kind of dependency, that question is worth sitting with long after this video ends. Drop your honest answer in the comments. If this breakdown delivered real value, the like button costs you nothing. Subscribe and turn on notifications. The next video goes directly after the anode problem Musk admitted remains unsolved, and the 3 companies most likely to beat Tesla to that answer first. That race is just beginning.